right, as we begin today, I want to just review some things that we've already talked about. Don't want to go over anything new. We're kind of stuck in the middle of exams right now. It's a Monday here as I'm recording this, Gavin, and time change weekend. So going a little bit easier here, spent some time going over the exam, and want to quickly review over some things that were already tested. I just want to brush up on some things and spend some time reviewing. I want you to look at number 10 at the bottom of page 148. So Gavin, if you'll go ahead and turn there, page 148. At the bottom of the page, we see review of solving inequalities. And number 10 is one that's really pretty straightforward. We got 3 is less than 2x is less than 6. And Noah, what would we need to do to solve this compound inequality? Divide everything by 2, right? And when we do, pretty straightforward, we'll get
3 over 2 is less than x is less than 3.
Good. Compound inequality is very straightforward. There's only one thing that can make a compound inequality hard. As you look at number 13, copy this down, do this with me now. Again, on the surface, this is really straightforward. There's 2 steps to get the x by itself. The first step, Brecken, is to simply add 2 to every part of the inequality. And Brecken, that'll give me and then Maddie, we simply divide away the. But because it's an inequality, one does not simply divide by a negative ever, right? Anytime we divide by a negative, Maddie, we remember we have to change these inequalities around. So yes, we have to divide by the negative, so we need to remember that negative 10 divided by negative 5 gives me positive 2. But then this symbol has to flip and become a greater than symbol. Of course, here we just cancel the negative 5s to get. And then here, this also has to flip around to become a, and we finally end up with a negative 2. But we cannot leave the answer this way. No, if we were looking at the number line here, 2 should be followed by 3, 4, 5, 6, 7, 8, all the way up to infinity. Negative 2 would never come after a 2. So this inequality statement is literally written backwards. So what we have to do is flip the whole thing around. The way I explained it earlier was, imagine yourself on the back side of the chalkboard. If I were behind the chalkboard, then I'd see the negative 2, the x, and the positive 2. And in fact, the symbols would say, from my perspective, looking this way, less than, wouldn't they? And that's exactly what we're doing as we flip it around. So we're going to start by listing this value first. Then this symbol, the point still needs to aim at the negative 2 as I flip it. So when I flip it this way, it becomes a less than. Then, of course, we get our... This symbol flips around, and then finally this appears at the end. So it still says that 2 is bigger than x, which is bigger than negative 2. But now it's written in the correct order. Does that make sense? Now, an important thing to point out, because the book doesn't give a lot of emphasis here, suppose this had been a less than or equal to. Less than or equal to. Flips around and becomes a greater than or equal to. But it's the symbol that associates with the negative 2. So here's where it goes. It almost looks like the symbol jumps to the other half of the inequality, but it's because you're literally flipping the whole thing around. Does that make sense? So when you copy down number 14, we're not going to copy it down exactly. I want you to write negative 2 is less than or equal to x, and then I just want a less, or 4 minus x, and then I just want a less than symbol before the 6, not less than or equal to. Okay, so just take off the or equal to on the last symbol there. Again, walk me through the steps. Maddie, we'll start with you. Good. From everything to get. All right. Now, Noah, we now have to divide everything by negative. Well, we don't want to divide the x away. What's technically the number in front of the x? Negative 1. So we just want to divide everything technically here by the
negative 1.
When we do, what do we initially write down?
6 is greater than or equal to x is greater than 2 or equal to.
Right, so initially that's just a straightforward divide everything by negative 1, the inequalities flip around and become greater than. But again, if you look at the number line, 6 is followed by numbers like 7, 8, 9, 10, 11, 12. Negative 2 never comes after a 6. So when we flip the whole thing around, what's it going to look like?
Negative 2 is less than x. It's greater than.
Oh, he's going to flip.
Or less than. Or equal to 6.
There we go. So that this mouth still opens to the 6. This mouth still opens to the x. Does that make sense? So again, it looks like the symbol moves places, but it's because you're literally flipping the whole thing around as if you're looking at it from the opposite side. Does that make sense? All right. I want you at your seats to go up higher in the review section and do numbers 1 through 7, the odd. 1 through 7, the odd in the review section in the middle of page 148. All right, check your answers on 1, 3, 5, 7. Again, all of them very straightforward except for 5. That's the one where we were having to flip stuff around because of the negative. Did we get all 4 of these right? On 1, 3, 5, 7. Brecken is saying yes. Which one? 5 continue to give you some trouble, all right. I assume you divided everything by the negative 2. Did you remember to flip these signs so instead of less thans, they became greater thans? Okay, so you did remember that. So you got to this statement here that positive 2 is greater than x is greater than negative 3?
I forgot to put the negative 3.
Which means as you look at it, you're like, I see 2, I see 3, everything looks normal, though 2 couldn't be bigger than x, and then x still be bigger than 3. So that wouldn't make sense either, would it? We kind of got a problem there. So yeah, the negative would have been the thing to flag you there. That's when we have to flip it around to say that negative 3 is smaller than the x, which is smaller than the 2. Kind of like instead of looking at it this way, looking at it from this perspective, negative 3 is less than the x, which is smaller than the 2, and they just keep getting bigger. Well, now we have to flip it so it still says the same thing. Negative 3 is less than x, which is less than 2. Maddie, how did you do? You got them all? And that was the only one that you missed was number 5, Noah? Let's do one more of those, and then we will move on. So let's suppose we had a negative 7 is less than negative 3x plus 5 is less than or equal to negative 2. All right, Noah, did you make it that far? Did you do one more step? Because this means 2 1/3. We can't have a 4 and then 2 1/3 come after it, right? So what should it look like?
7 over 30 is less than or equal to x is less than 4.
Perfect. Make sense now? You can go on that one. All right. Look further up the page now, and another thing that I wanted to kind of refresh our memory on were these absolute value inequalities. For instance, you look at number 2 in the practice section. So looking at the top section now, it says the absolute value of x is less than 5. Well, remember we said that anytime we have absolute value, the key is positive, negative. If this were an equal sign, we'd say that x was equal to positive 5 and negative 5. If this had said equal. But it doesn't say equal, it says less than, which means there's an entire range of values, not 2 individual values, there's a whole set of values. And so the key here is to draw a number line and to put those 2 key values, 5 and negative 5, on the number line. You've then got to decide where to put the x, either in between them or outside them. And in this case, class, because we have a less than, we put the x in between. So we would say that negative 5 is smaller than x, which is smaller than the 5. And we just put the x right in between the 5 and negative 5. But as we look at number 4, when we had, for instance, the absolute value of x is greater than 4, well, again, we see absolute value. The key to absolute value, class, is to think positive, negative. But it's not an equation. It's not equal to positive, negative. Rather, on the number line, I need to plot, class, 4 and negative 4. But because we have a greater than symbol, where is x? It's everything here and or everything here. So x is, what moves this direction, class, bigger or smaller? Smaller than negative 4, or my x values are greater than positive 4. I ended up with 2 separate pieces to my answer here. As we look at number 6, there's one more step, I suppose, that has to be factored in here. We've got that the absolute value of 4x is less than 8. Do this with me. We need to draw, class, a number line, and on the number line we need to plot 2 points. Negative 8 and positive 8. And then I need to take the 4x that's inside the absolute value, class, and I need to put it inside the negative 8 and 8. So I'm going to make one continuous inequality here. This is where the 4x falls. How do I write my inequality, Maddie? And now I just need to solve. One easy step, no adjust to get less than
x is less than 2.
And there's our answer. Pretty straightforward. Here, we just had to do the last step of dividing by 4. Look at number 8. We've got the absolute value of x minus 1 is greater than 4. Well, notice that looks a lot like this one, doesn't it? Where I'm going to start, class, by drawing a number line. And on the number line, I need to put negative 4 and positive 4. And am I going to go in between, or am I going to go outside? Outside, x minus 1 to this side of negative 4, and x minus 1 to this side of positive 4. So I'm going to get 2 separate inequalities, much like I did last time. Noah, how should I write my 2 inequalities?
X is less than negative 4.
Or we could also say,
X negative 1 is greater than 4.
There we go. But if it just said x, I'd be done. It doesn't. I've got one last step I've got to do here, Brecken. And then I get and there's my final answer. Questions on this? Questions on this? Look with me at number 10. We've got the absolute value of 3x negative 2 is less than 5. Well, again, I've got my absolute value isolated, so I'm ready to draw my number line. On the number line, class, not just Noah, plot both. And I'm going to put the entire 3x minus 2 inside. So what inequality do I write, Brecken? Good, but now I need to solve. First thing I need to do to solve, class, is add the 2 to everything. Of course, that'll get me and then finally divide everything by the, and when I do, what is my answer, Maddie? There we go. Look with me at number 12 now. And here, Noah, I cannot draw my number line yet. Why not? What's different about this and all the other problems we just worked? The absolute value is not yet, class, isolated. We've got to do that first. So before we can do any number liney stuff, I first need to get rid of the 2 by dividing it away. So that I should get and now I'm ready for the number line. Make sense? So we set up our number line, and on the number line, class, we plot negative and positive 4. What do I do with the 5x plus 1, class? I'm sorry? Put it outside. So I'm going to have not one continuous inequality, but 2 separate inequalities, Brecken. 4 is not greater than, it's less than, but the better way to say it is that the 5x plus 1 is greater than the 4. So the 5x plus 1 is smaller than the negative, but the 5x plus 1 is bigger than the positive. That's the better way to say it. So what do I need to do now? Continue. And of course that'll get me here, class, 5x is less than negative 5, or you can say 5x is greater than positive 3. So x is less than, or x is greater than 3/5. One more, and then we'll be done. Stay with me should the bell ring. Number 14. We've got a 5 times the absolute value of 4x negative 3 minus 2 is less than negative 1. Maddie, what first? Good, add the 2 to both sides, because we need to isolate this absolute value. Of course, that won't completely do it, but it'll get us a good start, won't it? That'll give me the absolute value of 4x negative 3. There we go. But I'm not ready to put my number line yet. I still need to. So that I really am ready to go now with the absolute value of 4x minus 3 is less than 1/5. Right? We're not flipping that symbol around. Now, class, I'm ready to put my number line. And now, this is exaggerated because positive and negative 1/5 are going to be really close to 0, right? But there's my positive 1/5. There's my negative 1/5. Noah, what do I do? On the inside. So what single inequality am I going to write? Right, the 1/5, because here's all of this stuff is 4x minus 3. So a 5th is at the smallest end of it. A 5th is smaller than all the stuff, but all the stuff is still smaller than the 1/5. Does that make sense? All right, and now, oh, I hate fractions, class. Let's just multiply everything by 5. What do I get if I multiply everything by 5? Noah? All right, now what do I need to do, Brecken? To get there we go. And to finish it out, class, just divide away the 20. Now, unfortunately, this does create some fractions I have to reduce, which is a little annoying. What is 14/20 reduced to, anyone? 7/10 is less than x is less than 8/10, or divide by 4, 4/5. And there would be our answer. Questions on the absolute value inequalities. Do you feel like we understand those better now? All right. Homework for this evening is to read page 148 at the top. Read page 148 at the top. And read pages 149 to 152. Read page 149 at the top, or 148 at the top, and read pages 149 to 152. Give you a preview of what's coming up in our lesson tomorrow as we do delve into new material tomorrow. Also, for written homework, I need you to do page 152, review 1 through 12. Page 152, the review 1 through 12. And on page 149, do word problem 23. Page 152, the review 1 through 12. And page 149, word problem 23. You'll need to have graph paper with you tomorrow for our next lesson. We're going to resume graphing again, so make sure you have that with you. All right, you are dismissed. Have a wonderful rest of your day.